All right, today's lesson combines two sections. The first one involves rational exponents, nth roots, and rational exponents. So our exponents look like fractions instead of just whole numbers or integers, and that's what objective one's about: simplifying expressions involving nth roots, and rational exponents. And then our second objective comes from the second section there, 6.6, and it's about solving radical equations. Good times. Okay, so start us off with objective one, simplifying expressions involving nth roots and rational exponents. So I did a little bit of investigating and I found a physics formula that's an application of rational exponents. So if you take a look at the actual function there, or the equation there, it looks a little scary, a little intimidating, but right down in the bottom, the exponent on the z squared plus r squared is 3/2. What? Crazy. It's a fraction, and that's part of what this objective is about. Okay, so this whole equation and stuff is an electric field due to a ring of charge, and I drew that picture myself right there. So just reviewing some square roots here. We know that a number r is a square root of x if you can square that number r and get x back. So we usually write it like this: square root of x equals r, where the x, the number that is underneath the square root sign, is called the radicand, and that term itself, square root of x, is a radical term. So just as an example, I can say that the square root of 9 is equal to 3 because 3 squared, not cubed, that's silly, is equal to 9. Piece of cake, right? Okay, so some of the things that we talked about before were any positive number, so like that 9 before, any positive number has two square roots, a positive one and a negative one, and this is the reason why. Right over here, so square root of 4 is 2, and it's equal to negative 2 because 2 squared is 4, and negative 2 squared is also 4. And we call the positive one the principal square root, and that's the one your calculator gives you, right? Yes. Okay, so whenever I'm evaluating a square root, I usually only have to write the principal one, and that's the one that's implied. It's just when I'm solving an equation, that's when I usually have to worry about it, when I take the square root of both sides, plus or minus. Okay, so let's move on to cube roots. So r is a cube root of x if you have to cube the number r in order to get x back. And we usually write it like that, where the 3 is right there in front of the, looks like a square root symbol with just a 3 in it. As a matter of fact, if you were to write the square root, you could write it like that, with 2 being the index of x if you wanted to. But, you know, we usually don't. Alright, so we could have fourth roots of x, we could have fifth roots of x, and that's also part of what this objective is about. So let's talk about the cube roots just a little bit more. So any positive or negative number just has one real cube root, and then it has two imaginary ones. As a matter of fact, that's what your challenge problems will be about in this section. They're fantastic. You remember sine, cosine, tangent, and unicircle stuff? They're back. Anyway, so like whenever you evaluate a cube root, the sign stays the same. So for example, the cube root of 8 is equal to 2 because 2 to the third power is equal to 8. If it was the cube root of negative 8, that's equal to negative 2 because negative 2 raised to the third power is negative 8. There's no plus or minus on this one. You keep the same sign of the radicand. Alright, finally nth root. So this just generalizes it to any root index. Still, n is the index. So before we were looking at cube roots, there we go. Finally, we could talk about fourth roots, fifth roots, whatever index root that you want to. So r is an nth root of x if you have to raise r to the n power, whatever that is, 3, 4, 5, in order to get x back. Okay, so on your calculator, how do you get those? Well, it's right underneath the math menu. So take a look over here at the calculator. On number 4, there's your cube root button. And number 5, it says X, and it has a little root symbol, a little radical symbol. So what you'd have to do is you'd have to put the index in first. Say if it was the 4th root, you type in 4, go to the math menu, choose number 5 there, and then type in your radicand, whatever that happens to be. So let's just try that on a couple of these. Let's pull out your calculator. If you have your own calculator, pull that thing out, turn it on, just like I'm about to do, and let's evaluate some of these cube and 4th roots. If you do not have your own calculator, hopefully you have downloaded this emulator and you can do it along with me so you can get the practice. Okay, so I want to go to the math menu to find that cube root button, and it's number 4 there. So right inside there, I'm going to type in 512. Nope, not that one. 512. And I get 8. Okay, just the number 8. Not plus or minus 8 or whatever, it's just
8. Okay, so now let's do the cube root of negative 512. So before, like when it was square roots, if it was negative, we didn't do it because it was imaginary. So is the same thing true if it's negative? No. Oh, what am I doing? I need to go to the math menu here. I need to choose number 4 and put in, this time, a negative. I wonder if that'll function as a negative sign now, just in case. 512. And I get, well, negative 8. It keeps the same sign as the radicand. Negative 8.
Alright, so let's do a 4th root. So the 4th root doesn't have its own button. You have to put in the index first. So my index is 4, and then I go to that math menu, and I choose number 5, and so it puts the little 4 as the index. Now, if you have the old operating system, it just puts the little 4 right out front. Don't worry about it, and you'll be fine. Okay, and then inside we're going to type in 625. And I get 5, because 5 raised to the 4th power is 625. So 5. Does that mean number 4 should be negative 5?
Let's see. So type that thing in there again. So the index, math, number 5, and this time negative 625. And it says non-real answer, right? It's imaginary because it's a negative and this is an even root. So this is non-real.
Alright, now then, I'm going to extend this, doing a little investigation so you can see something special here, and that is rational exponents. Now they're fractions. Let's just see what happens here. We're going to put these in our calculator and use the caret key in order to evaluate them. Let's pull that calculator up again, of course right on top of the problems, and clear this thing out. Put 512 raised to the 1/3 power. Now, for this one, since 512 is not negative, you can just type it in. Caret. Now, on the new operating system, it puts a tiny little exponent there. For the old one, it uses a caret, and you'd have to put this in parentheses. So I'm going to go ahead and put parentheses in there, just so you get in the habit. 1 divided by 3, and then close those parentheses. And I get 8. Oh, wait, that sounds familiar. 8 pen. Wait, that's the same thing as this. 1/3 and cube root. Interesting.
Let's try another one. Okay, so this time the 512 is negative, so I need to put that in parentheses starting. So negative, nope, not negative, that's in the minus key. 512, whoa, double negatives there. They cancel each other out, delete. Close the parentheses, raise that to, open the parentheses, 1 divided by 3, close the parentheses, didn't open them. Okay, now I've got negative 8. Negative 8, hey, that's also the same thing what was over here. Negative 8.
So it seems like this 1/3 is the same thing as a cube root. So what do you think this 1/4 is? That 1/4 should be the same thing as a 4th root. So that should be equal to 5. And since this is a negative number underneath a 4th root, which is even, this must also be non-real. So there it is. We have some rational exponents, and what they mean are the same thing as nth roots. Half would mean square root. Well, just take a look at this. Okay, so let me prove this to you. Would you agree that the square root of a squared should be equal to a? So those things should cancel each other out, and I just get a back because they're inverses. Squaring and square root. Okay, so what I'm going to do is I'm going to let a to the x equal the square root of a. Because what I want to do is I want to figure out what is the exponent that means the same thing as square root. And that exponent is my variable x. So I'm going to take this out on the left-hand side and put a to the x in its place. Okay, over here on the left-hand side of the equation, you just got a power to a power, so you multiply those exponents. So that's a to the 2x. And that is the same thing as a to the 2x is equal to a to the first. I just put that exponent on there because if the bases are the same, the exponents must be the same. This means that 2x must be equal to 1. What does x have to be? 1/2. So there we go. We just solved for what that exponent has to be. The square root of a number is the same thing as a number raised to the 1/2 power. Here it is with cube roots. The argument is exactly the same, except for now we're talking about cube roots. So cube root is the same thing as 1/3 power, and then if I'm talking about nth roots, it's the same thing as the 1/n power. Alright, so there you just learned something new, something you probably never ever seen before. So let's do these without a calculator. Should be pretty simple if we know our cubes and stuff. Okay, so 343 1/3 power is the same thing as the cube root of 343. And unless I'm mistaken, I believe that that is equal to 7. Okay, so number 2 means 343. It means the cube root. 1/3 power means the same thing as cube root, and you can take an odd root of a negative number. Oops, I forgot my little index. And the number stays the same sign, so -7. Okay, on number 3, 16 to the 1/4 power, same thing as the 4th root of 16. 4th root of 16, 2 times 2, 2 times 2 is equal to 2. And on number 4, this would be the 4th root of -16. Since this is even, and that's a negative number, that is not real, my friends. Okay, so that concludes this video, and we're going to take it up a notch in the next video with some more rational exponents.